So Exam2 review. On question number 2, a lot of people ignored this second question, this second part. So I definitely wanted you to use a model for subtraction to illustrate and explain 3.4 minus 1.6. So I expected base 10 blocks. I expected pictures of those blocks and an explanation about what you were doing. You had to state what model you were using. You have two options here. You could have used the takeaway model or the compare model. And so there are a lot of people that just didn't state why they were doing what they were doing. So first thing we always do is we say, okay, subtract means, tell me what subtract means, then tell me what it means for these two problems. So I prefer the comparison, so I would have said subtraction means to compare. In this case, it means how much bigger is 3.4 than 1.6. Then I would show the base 10 blocks and do a trade if I needed to, and there was a trade necessary. Next thing after that illustration and explanation, you should have said how that illustration and explanation related to the borrowing in the standard algorithm. So that means you have to actually show the standard algorithm and talk about it. In particular, make a connection between the trade in the base 10 blocks to the borrowing that happened in the algorithm. Similar thing for multiplication. Now multiplication, I told you what model to use. I said use the area model. It would have been nice up front if you said area is multiplication, which means base times height, and then carried on with the picture and the explanation. I expected a neat picture. Most of them were neat, but then a significant part of the class just didn't even address this part here. So here you had to show the standard algorithm and show anywhere carrying happened in the standard algorithm and how it related to how the illustration gave an answer. So again, look back at mine to see how I did my illustration and explanation, and then how I related that to the algorithm for subtraction, the algorithm for addition. Division one was pretty straightforward. There's examples like that in the book. Almost everybody got that right. Lots of problems on number 5 here. So here we had these repeating fractions, right? The bar over the top. And whatever fraction you came up with, you could test to see if it worked. So for example, the 0.27 repeating, if you thought the answer was 27 out of 100, then if on a calculator you type 27 out of 100, you could check, do you get a repeating decimal? Right? So that doesn't repeat, so that can't be the answer. If you had a slight error when you were cleaning it up, you could always type your fraction in to see if it gives the decimal that I showed there. So there were lots of examples that people didn't check their work to see that they did it right. So please take a look at my work, check the fraction you wrote to see if it actually matches the ones given here. And there were more mistakes there than I thought I would have seen there. And again, I'm not going to show much work right now. I just want to talk about it just because I provided my answers. My answers were pretty detailed. How can you determine if a fraction will terminate as a decimal by looking at the denominator? Provide multiple examples supporting your claim. About a quarter of the class just made a statement about what they thought was true and provided no examples supporting their claim. So that was an important one where you really needed to have multiple examples to show what you said is true or not. So I was expecting there at least 4 examples, a couple showing that, hey, this is what I think, here's examples of where it's true, here's counterexamples where it's not true. The number line one, so we did this a bunch of times with fractions, and there were some homework problems kind of like this one right here. There was a significant amount of trouble. I thought this one was going to be easier than the fractions, so this one I actually do want to do right now because there were way more people that didn't get 100% on this one than I thought should have. So some things to consider about pi. And let us, where's my whiteboard? There it is. New page. So I'm trying to find real numbers between 3.14 and pi. And I want them graphed. So pi is the classic example of an irrational number. Irrational numbers have decimals that go on forever without repeating. So if we put pi in a calculator, it will give us more than just 2 decimal places, and there's lots of calculators to choose from, and they all show a different number. So pi on Desmos gives me 1, 2, 3, 4, 5, 6, 7, 8, 9 places of pi. If I use the Google calculator and ask for pi, it gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 decimal places of pi. How many decimal places does pi have? Unfortunately, it has infinitely many. Problem with those infinitely many is they're hard to draw on a number line. And so we have to be careful about how we proceed here. So 3.14 is a common approximation of pi, but it isn't pi. And even the number I have right here on the screen isn't quite pi, because pi keeps going. But for my human existence, that's probably the max that I can deal with intellectually. And like, what place is that? Let's see, 10th, 100,000, 10,000, 100,000, million, 10 million, 100 million, billion, 10 billion, 100 billion. That's like a trillionth there. So pretty tiny amount, measurable. So there are lots of choices here. So pi is about 3.14. According to those calculators, it's also about 3.1415926, and I can't remember anymore after that. But that's more than enough to go with right here. So if I were doing this, lots of ways to proceed. Over here is 3.14. And then way over on the other side, let's draw a straight line, I would put pi. And then for now, I'm just going to call pi about 3.1415926. All right, so then I have to split up the number line here. Now I wanted, what, 5 numbers in there? So one easy way to do is to split this into tenths maybe. Ten parts between here and here. So let's see, if this is the nearest hundredths, excuse me, then that means I would want to use thousandths. So I want to count by thousandths up to pi. Let's see how that works. So then I could call this 3.140. It's exactly the same number as 3.14. And then numbers I could go in between here. So let's see, this is 3.1415 roughly. If I go, let's see, it's not going to work. 3.14, let's go to 15 is somewhere just inside of pi here, 3.1400. So in between here, I could have 3.1401 and 3.1402, leading all the way up to 3.1415, 3.1403, and so on. What's going to be right in between 3.1400 and 3.1415? You can average those two numbers to find out what's in the middle. So let's do that for fun. 3.1400 plus 3.1415 divide by 2. So right in the middle of those two numbers would be like 3.14075 or 08 if we rounded just a little bit. So back here, so roughly in the middle, let's say that's about the middle right there, would be about 3.1507-ish in the middle. So I didn't need it to be perfectly set, but I needed them to be roughly in the right place. So this is, again, 3.1400. And could I have called this 3.1416? Would that be an okay number to use here?
Yes.
Okay. Answer is yes and no. So pi is 3.14159. 3.1416 is just a little bigger. So this red number probably lives about right here. And my blue number probably lives more over here-ish. So this would be about 3.1415. So this question wasn't that hard, but it wasn't that easy either. You had to think about it a little bit. So right now I have 1, 2 numbers in there, and so then I just need to put a few more in there. There are, if I stick with this 10, tens, hundreds, thousands, 10 thousandths, there would be 6 marks in between here. So let's see, 1, 2, 3, 4, 5, 6. So that would be about the position of 3.1401. And so, oops, that would be 03 and so on. So I could easily put a whole bunch in there, but a little bit of care had to be done to get them in there. And so not enough care was taken to make sure the numbers you found were actually in between here and here, or getting them in the right spot. Some people had some clever ideas, like use 3.141, just keep adding other decimals, and then 3.1415, and then 3.1415, and then next you could do 3.14192. And if you round any one of these up, it jumps on the other side of pi, not inside. So rounding was an important skill to think about here. If you did try to do that right there, 3.141 would be about, let's see, 07, 08 would be about right there, 09, 10. This number right here is 3.141. If that's 3.14, and that's 3.1415. 3.1415, notice that's this one right here, that's right there. And then if we go 14159, that ends up being pretty darn close to pi. And then this one right here, you can't even see, it sits right on top of pi, it's so close. You'd have to really zoom in there to see that it's closer. Because again, remember what's going on with these places. This place here is 10 times smaller than that place. And so we're really zooming in every time we add another place here. So although this is an interesting idea, they're not graphable together on the same number line in an easy way. And again, just notice where the first option is. If we go one more place, that ends up being way over here. Notice how quickly we zoom into pi right there. So look back at what you did, think about it a little bit, think about how you could have done it better. Important not to repeat mistakes. All right, what else? This went mostly good. There were some subtle errors, not realizing this was less than 1%. So most common error was either not reading that properly and then forgetting that 1/3 does not make a good decimal. So either we have to show that we rounded or we have to use a repeating bar on that one. So common errors were here and here. And then these two problems were hard. That's why I gave you a choice on them. And mostly those went pretty good. I was pretty impressed with the things people did on those two. So I'm not going to go over those two right here, but I do want to take a look at this one right here. Now on this one right here, I said to solve this by using the bar or the square. So I needed to see your solution that you showed first clearly was based on your bar or your square. After that, definitely check it with something else like a proportion. And so that's what I showed in my answers, if you take a look at that. So, so again, kind of key points relating back here. I think the two most important ones for me were check your work, check your work, check your work, check your work. This was a take-home exam. You should have taken the time to make sure what you were submitting was good. I don't expect everything to be perfect. We all make mistakes. Not a big deal, but there were a lot of things that I think people, if they looked more carefully, would have caught their errors. And the other thing is make sure you answer the question I asked and didn't miss any part of it. So there were times when there were explanations without illustrations or illustrations without explanations. If it says illustrate and explain, be sure to write a certain amount of words. The general rule on any kind of illustrating explain, looking back from last quarter of Math 211 to this quarter in Math 212. So illustrate and explain. Anytime you see a problem like this, and there will be a couple of these on the final, this is for operation models. So in this case, for the final exam, it's going to be add, subtract, multiply, or divide for fractions or decimals. The first thing you want to do is you want to just be clear, state your definition. The final is going to be, I'm going to post it on Monday, and you'll be able to take it Monday, Tuesday, or Wednesday. But there's going to be a time limit on it, and I'll get to that in a minute. So let's see, state what the operation means. Right, so for example, here, you might do something like subtract means compare. And then not only do you want to do that, you want to state what it means in context of the numbers. So you're going to state what the operation means and use the given numbers. Right, you want to demonstrate you clearly know what you're talking about. So continue this example for the subtract means compare for that problem on the test. I would say how much bigger is 3.14, or maybe it was 3.4 than 1.6. Right. So up front, what does the operation mean? What does it mean with these numbers? Then you start the illustration based on that. Right, so every time we model something that we state what an operation means, it asks a question, then we can take that question and turn it into an illustration. The next thing we need to do is explain how the illustration shows the answer. So minimal on any type of illustrate and explain is you got to upfront state, okay, this is what this situation means with these numbers, start the illustration based on what you said above, and then explain how the illustration leads to the answer, okay? Often I will then say, okay, how does that relate to the algorithm? That's a whole nother question that I ask separate for those problems. I don't often ask that, but sometimes I do. So you want to definitely look up for that. But minimum 3 stages. You have, what does it mean? Illustrate based on that, explain the illustration. Setup, illustration, conclusion. All right, so that's super important on those right there. So let's see, we're almost out of time. Darn it. So as far as the exam goes, show the desktop. I need to post some more things. So I'm going to post a bunch of practice problems that are optional. So I'm going to add, might as well do it right now. And I've already added some of this. I think I mentioned the other day under course information, under resources, I had a sample final. Usually I give an exit exam in this class, but the problem with the exit exam is then that's something I have you show me, you know how to do arithmetic without a calculator. I have no control over that, so I'm not going to do an exit exam. I was thinking about doing one, but the only way I could do that is to do something like ProctorU. I don't know if you guys are familiar with that. That's where some stranger watches you through a camera while you do your test. I find that a little too creepy. So we're just going to skip the exit exam. I'm keep going back and forth onto whether the final is going to be in 2 parts. I think it probably will be, where I'll have one part that you just write some stuff on paper, and then the other part's kind of be like the homework, where you have these problems that appear for you, and then you type in the box the answers, and then there'll be a place for you to submit the work. So I haven't quite decided whether it's going to be all in one, but what I'm going to do is I'll add. The exit exam is out. I have one sample final here. I was going to bring up another one for you to look at from a previous year. So this is just a practice from before. I think we got to all of this stuff, except we didn't get to expected values. So question 24 was the last part of 8.2 we didn't get to. So I'm not doing anything like question 24. But otherwise, we covered everything else in here. So I'm going to post, this was 2015. I'll post another more recent final, and I'll see if I can dig up some answers. So in the next day, look for some announcements. So I'll have an announcement up here, and then there'll be stuff appearing down here. So I'll have some samples down here, and then more information about how the final will be. So one of 2 things will happen. Either you'll have like a 1 day to get the final done, either on Monday, Wednesday, or Friday, or the final will be in 2 parts, like a take-home part and then a timed in-class part. And I still haven't quite decided what to do there. But I will decide by tomorrow, and I'll let you know about it. So the final will have to be turned in by Wednesday of next week, so I have enough time to get it graded by Friday morning. All right, other questions? All right, so look out for an announcement from me by tomorrow, and then some more stuff in that final exam section at the bottom, in particular a sample final, and then more information about the format of the actual final exam. So that's it for now. If you have any questions, make sure you email me or message me from the homework. Good luck with the rest of your finals. Thanks for playing with me. Take care.